I just wanted to show a quick way on how to transform, rather convert numbers from binary to decimal and vice versa. And I found out this method when they taught me binary and decimal in high school. I thought it was pretty obvious to see, but when I explained it to my teacher and classmates, it kind of surprised them, and not many of them even got it. So I will try to explain this. It makes it a lot easier. For example, I have a random binary generator here, right? So we'll generate a 6-bit binary number because, well, it has to be concise, small. Oh, I have to stop it. Okay. So let's see. I did not expect this, but we transfer it to paper just for ease. So as you can see, we have, I apologize for the quality, but as you can see, we have 30101. Now, if a number starts with zeros, you neglect all of those zeros, right? I don't know how to make it more visible, but if a number starts with zeros, so you can just neglect all of those zeros. And then this one stands for 1. You know, when you transform decimal, the way they teach you in middle school, high school, is you grab a number, you start dividing it by 2, and if it divides by 2, you write 0. If it doesn't divide by 2, you write 1, right? And finally you get a 1. You must finish your number with 1. So that 1 represents that 1. So this is 1. Now a 0 follows it. That means that it was divided by something, right? The number that preceded 1 was a number that divided 2. So if it's 1, the number preceding 1 that divides 2 is 2, right? So if it's 0, we can just multiply it by 2. So 1 times 2, that's 2. And then we have 1. So that means that something did not divide the number preceding 2 by 2. So we have 1, then we have 2, and if it's a 1, we multiply it by 2 and add that 1. Does that make sense? So it's 2, right? We multiply it by 2 and add 1, and we should get a 5. Now if we check this on a website, it should show the same answer. Exactly. Well, it's kind of hard to see this camera. I understand, but you can check it yourself. It's 5 basically. So I can do this for a couple of more numbers. Let's try at 8 bits actually. Okay. That's a fair enough number. So I will write this number down quickly. We have 5 zeros, a 1 and a 0. This is a standard binary number, right? You don't have any zeros preceding it. I'm not sure if I should call it standard or not, but I prefer to think of it that way, because this is a clear result from a decimal number, right? So basically, you have the one that ends the entire number, so we keep it as 1. Then it's a bit tough to see, but we have 5 zeros. 1, 2, 4, 8, 16, 32. And now we multiply 32 by 2 and add 1. So that gives us 65. And we multiply that 65 by 2, and that is 130. So that should be the result that our website gives us, hopefully. I did say 130, right? Yes, that is the answer. And now let's try to Let's try to convert decimal to binary with the same method. I've never done it, but it should be easy. Let's random to 1 to 100, right? Okay, 51. That should be easy. So we start. So 51 does not divide 2, right? So write 1. Then we have we get 50. 50 divided by 2 is 25, right? 25 again did not divide 2, or rather 2 does not divide. I'm not sure how to put it, but basically you get a 1, and 24 divided by 2 is 12, and 12 does divide 2. So we write a 0, we get 6, 6 does divide by 2, 3 does not, we write a 1, we get a 1, and that 1 is also, so I got 1 1 0 0 1 1, and if we check the website it should give us the same results. So we had 51, right? Yes. It's 1 1 0 0 1 1. So again, it's not visible, I understand, but just bear with me. You can check yourself, and it should be clear. Now, I'm not sure if I explained it right. I'll try to go over the method again, because it might be confusing, and it will be confusing. So you must think of this logically, right? So you have a number, and of course when we get a binary number, the 1 stays at the left side, right? At the leftmost side. So you keep that 1 in mind as 1. And then the number that preceded 1, so we got 1 from a number that did not divide 2. That's why we wrote 1 here, right? That makes sense. So if it did not divide 2, that means then 1 was that number did not divide 2, so we subtracted 1 from that number and then divided by 2. So 1 times 2 is 2, which is the number we lastly divided by 2, but we first subtracted that 1, so it was initially 3, right? If it's a 0, that means that the number preceding 3 did divide 2, and we know that the only way we get a preceding number is by multiplying it by 2. Multiplying it by 2 or multiplying it by 2 and adding 1, so there's no like 3 times 4 times, it's just 2 times. So if it's a 0, we get 6, and there's another 0, so that's 12. There's 1, so it's 25, and there's a 1, 51. And well, that's about the method, really. I'm not sure if it's not taught anywhere. I'm not claiming that I've made a grand discovery or something, and I understand that my school, it might be just my school that did not teach this at the time, and it might be different across the world, it might be different across the countries and schools, so I will keep that in mind. So please do tell me if you are familiar with this method, because I am very curious, because I explained it to my math teacher a couple of years ago and he just did not understand it. I'm not sure why, maybe because my explanation skills are not the best, but still I think it's a very easy concept to see. It's a very easy notion to get a hang of. So I think that it's not the hardest thing to do. And I just wanted to point out that I don't claim to be a mathematician. I was never really that, a classy nerd guy that dedicates his life to science and maths. I do respect those people, but I was never one of them. I was just kind of a guy that happened to be good at maths because I saw stuff like this. I saw patterns and interesting ways to interpret the formulas and the logic behind maths. And that's why I think maths in general is very interesting. I'm not familiar with higher maths yet, although I'm very familiar with school maths and I love it. I love school maths and I'd gladly teach people school maths because I believe I can maybe explain it in a better way than a teacher or school curriculum does it, because it's kind of very superficial. It's just a formula, and I hate formulas. My favorite part of maths was geometry because you actually had to see stuff, right? You had to keep in mind ideas that you've learned, and you had to utilize those ideas into a higher notion. So that's why I think that geometry is the best part of maths, and that's why I hated algebra because, well, I did not hate algebra. I was good at algebra as well, but I did not enjoy it per se because it was tougher to find these patterns and it was more mundane. So I think I think that if I gave it some time, I could find stuff like this, that would make it more fun, that would make it easier, that would make it more accessible to everyone. Because I don't believe that there's such thing as bad at maths, right? When people say, "Oh, I'm just bad at maths," I think that it's just a how do I put this? Um, it's kind of a predetermination, as ridiculous as bloody nonsense, and I think people should just find ways that suit them best to learn stuff, right? So if anyone asks me for my biggest advice to learn stuff, it's arbitrary stuff like methods and apps and software and resources and etc. But the most important advice that I give anyone is first and foremost you must get to know yourself. I know it's not easy to understand. It's easy to say, it's not easy to grasp, but you must understand what methods suit you best. You must understand how your brain handles information, what kind of information your brain handles best, and you must basically get to know how your brain works and your character, everything. You have to keep all of that in mind when trying to learn something. That when you follow a method that you created or you found on the internet that is applied, that is suited for you, it's much easier to learn something than following a stereotypical acknowledged way. I understand that it's acknowledged that it's a sort of a guarantee, but I think risking a couple of like a year or something to get to know yourself and then accelerating your study is much more beneficial. You don't even need to spend a year, you just need to spend like 2 days thinking, and the life of observation. So if you're not lazy, you'll get to it, and it's not necessary to know maths as well, right? If you just don't like maths, it's okay. You can just not like maths, and you can live with that. I don't see an issue with that. But not liking maths before knowing maths, I think that's an issue. Because you have to kind of get to know everything in life more or less on a general level, because the subjects of life are very colorful and very interesting, and you are missing out on a lot. And the stuff they teach you at school is not general level. It's kind of scattered. It's kind of it's confusing as well, because it's all of it is kind of piled upon you at the same time in the same environment, which makes it hard to differentiate, makes it hard to study, makes it hard to focus. And when you're kind of sitting by yourself at home, when you get books of math, sites of math, and you kind of create this environment. You kind of get the visual, the atmosphere of the subject. It's much easier to learn, I think. So yeah, this video has gone on for quite some time now, so I should be bidding my farewells about now. Peace.